Hi everyone, I'm Inshaaf. Today I'm going to talk about reactance of capacitors and inductors. When considering AC circuits, the ratio between voltage and current depends on frequency. Hence, generally the ratio between voltage and current is expressed as impedance Z. Reactance is the impedance of inductors and capacitors in AC circuit, and it is expressed as the ratio between sinusoidal voltage and current, and it is frequency dependent. Now let's look at the reactance of a capacitor. We know that the Q is equal to CV and the current is equal to capacitance times the derivative of voltage. The sinusoidal voltage and the derivative of the sinusoidal voltage multiplied by the capacitance gives you that sinusoidal current, which clearly shows that the current is leading the voltage by 90 degrees. Hence, the ratio between voltage and current is given by 1 over omega C, which is the reactance of a capacitor measured in ohms. Let's look at the reactance of an inductor. Induced voltage V is given by the derivative of the current times the inductance. Sinusoidal current and the derivative of the current multiplied by the inductance gives you the sinusoidal voltage, which clearly shows the voltage is leading the current by 90 degrees. Hence, the ratio between voltage and current is given by omega L, which is the reactance of an inductor measured in ohms. Angular frequency omega is given by 2 pi into frequency. Hence, the reactance of a capacitor can be given by 1 over 2 pi fc, and it is inversely proportional to the frequency. On the other hand, reactance of an inductor is given by 2 pi fl, and it is proportional to the frequency. Capacitive and inductive reactance are represented graphically along the imaginary axis. Reactance of a capacitor is represented along the negative imaginary axis with an anticlockwise angle of 90 degrees. Hence, a negative J is associated. Therefore, the reactance of a capacitor is given by negative J over 2 pi fc. On the other hand, reactance of an inductor is represented along the positive imaginary axis. Hence, a positive J is associated, and therefore the reactance of an inductor is given by J 2 pi fl. Let's do an example. Determine the reactance of capacitor and inductor where both circuits have a frequency of 60 Hz. The first one have a capacitance of 100 microfarad and the second one have an inductance of 10 millihenries. Subbing in the capacitance and the frequency to the capacitive reactance equation and inductance and the frequency to the inductive reactance equation, we would be getting 26.5 ohms as the capacitive reactance and 3.77 ohms as the inductive reactance. Thank you.